actually be really nice if I just had some kind of little widget that I can see easily while I'm recording that would show me the status of both the streams and the recordings and, you know, anything else that I need to keep track of while I'm running this mayhem thing. There's like a Linux box that actually runs the stream on Nginx, and that's probably where I'll write the code behind this. And so I could just plug a monitor into that machine, but I'd actually prefer to have something that is both more legible and smaller than a monitor. This seemed like a good opportunity, by way of long-winded introduction, to revive an old project. Let's see, can we count these? 4, 8, 4, 8, yeah, so that's 20. 20 by 2 20 by 2 VFD. I'm not used to saying VFD. It's been so long. This is from the age of really, really early USB. Because like I designed this with stuff that was relatively hobbyist accessible in 2003, which is still when a lot of people were just getting USB ports on their computers. You'll notice it has both an IEC style power input jack and USB with a captive cable. This was me following the USB spec really closely because the VFD drew a little over 500 milliamps, so I didn't want to like burn out anybody's USB port. Well, I think the VFD plus the infrared transmitter especially would have drawn more than that, because I think the IR was maybe 100 milliamps or so on its own. The IR transmitter is external. This RCA jack leads to just a little IR doodad or like a Y cable with a bunch of IR LEDs. So yeah, be gentle on me. I learned a lot when I was building this. But you should be gentle on everyone. I mean, I don't like it when people are really snobby about knowledge. It's not how you learn stuff. 2003, something around there. Anyway, early 2000s. There was kind of a small version and a large version of this project. I was interested in building stuff with USB, but USB was still not super easy to use, and basically the form that I encountered this stuff in was a series of microcontrollers, PIC16C 745 and 765, which were really the same die, just bonded out with different numbers of pins. Front side. Now I can start to see the vintage stuff. I mean, the options at that point were either to program it in assembly, which I was actually pretty used to. I'd done a bunch of PIC assembly at that point, so that wasn't a big deal. Or to use some, expensive C compiler. I think at the time the compiler that all of their official code used was way out of my price range. Chapter 9 refers to the part of the USB spec that actually lists out all the things that you can tell a USB device to do. So that's mostly where the actual functionality of a device gets stuck in the implementation. So this looks like I added some external functions, VFD send by, IR send by, IR flush. Descriptors, this is where you might have seen these feature in the earlier glitching video. This is where you ask a USB device to identify itself and it returns a little bit of memory. Yeah, oh, and this was weird. This was super hacky because I was having trouble with the USB serial engine and getting it to handle data packets correctly. So I just stuffed 4 bytes into the available fields in the header for the control request. And so you write to the VFD 4 bytes at a time with control requests. It was really slow. But the serial port was also slow, so it didn't really matter. Yeah, so this case, I think I got this at some local electronics store or something, and then painstakingly cut everything out with the Dremel and didn't really do a super straight job of it, but it worked all right for my needs. Let's take a closer look at this thing. So here's the power jack grounded to the chassis. I'm soldered. Probably should have heat shrunk some of this. I don't know why the hot has a heat shrink and not the neutral. It's kind of weird. So the small project and the large project. The small project was the Media InfraWidget 6000. The big project was Wasabi. I think we had some kind of grand vision at the time of maybe starting a company to build set-top boxes around open source software. But we wanted to see if we just liked building set-top box software first, so we just tried building this as a hobby project. And it was alright, but it didn't really take off. One of my favorite remnants from this project was actually some of the artwork I did for it. What even was this? Oh yeah, the GameCube hub. This was a thing where you could plug 4 GameCube controllers into it, and then it attached over USB. So in the original Media InfraWidget 6000, it was the little you know, this thing that was about the size of a deck of cards that had infrared transmitter LEDs and one of these little demodulator receiver devices, and had firmware that would just interrupt every time there was an edge on that demodulated signal, and it would, over USB, what you got was this kind of FIFO buffered stream of timed intervals between pulse edges. And then there was software on the PC side that was actually responsible for using that to recognize different remote control codes. There was an existing system I was trying to be compatible with called LIRC, or the Linux Infrared Control subsystem. Portable Media InfraWidget 6000. So we had kind of all the boilerplate stuff, the decoupling and the crystal, some LEDs. The IR detector was just the thing that you plugged in. Here the LED is self-contained, but in the other version the LED is separate, so I think I wanted to be switching on the high side of the LED rather than on the low side, so that the low side could just be grounded. So here I'm using a PNP transistor, which acts like a current amplifier. This is the set-top box. So yeah, same IR circuit over here with a 10 ohm resistor in series, I think, just to keep people's LEDs from burning out with the high current pulses, but I don't know if that was actually necessary, because this will also end up acting to limit the current as well. And this time I'm switching the low side of the VFD. So the VFD's ground is normally floating, and then I ground it with this big NPN transistor. Anyway, and I think this was just a random power supply from a surplus shop. What is that rated at? 5 volts, 1 amp? Which, it's like really weird to have a USB device with its own 5 volt 1 amp power supply, but that's what I did. This is the ultraviolet EEPROM style microprocessor. Back before flash memory was common, somebody at Microchip mentioned that this is one of the last processors that they made in the windowed non-flash memory ultraviolet array style. First processor with USB, so weird little overlap there. You can see I recycled some of these connectors from like old PC case stuff. So yeah, there's a little sticker on there to keep light from erasing the chip and also label it with a revision number. Oh, over here we got some transistorage. I mean, the actual VFD it's this glass vacuum tube. And then you can see the hot nut, which doesn't look bad from the front. These were, if I remember right, really ugly non-diffuse LEDs, so they're kind of eye-pokingly bright. This was a really nice VFD unit. Like, I was surprised to see these going for $20 each on surplus at the time. All the basic parts of switching, like a flyback converter or something similar over here. I haven't actually traced out this circuit, but transistor, capacitors. This might be easier to adapt, actually. I had a Python thing. Oh, how does this work? This right VFD, how does that work? Oh, Century VFD, I guess that's the brand name. Oh, neat. This would have been hard to figure out. It's nice having already written code to do stuff like this. Present me thanks past me for some of the things that they did. The way I envision actually mounting this is, instead of a giant set-top box thing, I kind of want something that I can like magnet onto one of my light poles. So it would just have like a U shape with magnets embedded inside it that would hold on there, hopefully very snugly. I don't know what this was for. Certainly wasn't keeping the electrons in. It's a cute little power supply. Oh, there's the optocoupler. Oh, that's such a nice little thing. So it's got feedback, it's got some good isolation. I mean, I remember these being actually pretty legit power supply modules. LEDs are just hot glued in here. We can use everyone's favorite hot glue release trick. This is 99% isopropanol. And I think this will just cause the LEDs to pop right out. Oh man, look at that. It just comes right off. We might take a closer look at the IR doodad, since this one's so anachronistic, being like its own circuit board and everything. This stuff's already starting to come off. I think I salvaged this off of something. I think this was pulled off of a old VCR or something like that. But it would have been circuit board mount, so if my hand is the circuit board, and it would have been facing upward. So there's probably like a circuit board in the front of your VCR that has a bunch of buttons, or like DVD player, something that has a remote. And so there would have been a circuit board here with LEDs and buttons and stuff, and this just mounted on top. This needs a little more isopropanol. Delicious. You see that? That kind of looks like I tried soldering this to the front, which I don't think that would have worked for a number of reasons. Well, mostly the case being aluminum. Whoa, this is very old school, actually. I've seen devices like this, IR receivers, that have a, like an epoxy blob, but this one seems like it's all like, so there's an SO8 surface mount chip, which is going to be the amplifier demodulator, and then the actual photodiode is a through-hole part. Retweet if you're old enough to remember turbo switch. Retweet if you're old enough to have written code that needs the turbo switch. Retweet if you've ever written an emulator that emulates the turbo switch. And retweet if you've ever checked whether someone else's or turbo switch emulation is cycle accurate. Yeah, that rabbit hole goes deep. So, there's the circuit board. Home etched. I wonder if I put anything over this to keep it from oxidizing, or if I just got really lucky. One large transistor, 3 smaller transistors, and the microcontroller, not much else. And then on the back side, all the traces. So, you can see how I had to solder that connector on the bottom. And the traces seem to have held up pretty well. A few little drips and mistakes, but it's not bad. Single-sided board, all drilled by hand. This is a really interesting packaging technique that was pretty archaic even at the time this chip was produced. So the package was ceramic, and there's this, I guess it's gold-plated, I don't know what the base metal is, and the window itself is made of quartz, so the UV can pass through it. As you can imagine, these chips are more expensive than something you'd usually want to ship. Like, I think each of these individual chips was maybe like $7 or $8 at the time. Whereas, you know, they were designed to be something you'd put in, like, really mass-manufactured products, so you wouldn't leave the windowed version in for any longer than you had to. You know, by shining light on the die, you can change the amount of leakage in the analog to digital converter's input. So I had a program that would make the die itself into a light sensor just by charging up the analog to digital converter capacitors, a lot like you would do like a capacitance, like a capacitive touch sensor. I mean, so this big region here is almost certainly going to be our, well, I was about to say flash memory, our EEPROM memory. This stuff here is likely RAM. I don't know what else to do with this circuit board. I mean, I might just hold on to it for posterity, one of those words. Is it lucky to hold on to old microcontrollers? Well, if you have any thoughts about what to do with this, let me know. Otherwise, it's probably going to sit in a box of old projects indefinitely until I get tired of it. There we go. That's the thing. That's really pretty. I suspect a lot of you have seen the construction behind VFDs before, but to really quickly summarize, it's a vacuum tube that excites these little phosphor squares that glow green. The electrons for this excitation come from some really thin wires, which you probably can't see now, but they'll glow just a little bit when it's on because they heat up. You can modulate which dots light up, both by controlling which dots, like which targets are actually sinking current, and by using those vertical grids to actually mask off individual characters. So that's how this does multiplexing, by actually acting like a vacuum tube and switching current on and off to individual pixels. So that's why we don't need a pin for every single pixel, just for all the pixels on one column, and then for all the columns, and then for the grid. You can see the fine grid wires over there held under tension by little metal springs. You can kind of see through and see that there aren't really any components under the VFD, which is probably good. And the VFD itself is a couple of layers of glass bonded together with some kind of spacer allowing the lead frame to poke through. So clearly we have an array of these identical VFD driver chips, and then kind of one main driver which probably does all the fonts and everything else and actually has all the smarts in this thing. God, it's getting warm. This is the right company. So that's the IEE logo we saw. I thought that was some kind of certification at first, but that's the company name. So here we've got 5 volts on 2 and 4, ground on 6 and 10. Oh, I guess we can ignore most of this. So this is broken down by whether the parallel bus is in Intel or Motorola mode, but we're just ignoring the parallel bus. So we're using the 2 5 volts, yeah, 6 and 10, so this matches what we have. Let's go ahead and save this datasheet. So usually these are made with dark plastic panels in front of them. I don't actually have any of that handy, but it might be worth seeing what I could come up with. I don't know, it's nice to see the tube. I'm all for improving contrast, but I don't want to hide the tube too much. Well, here's all the control codes. That's nice. I think we've already got a Python module that'll do the trick, though. Something in this pile will get us into this. Start with the finesse, maybe. It looks like there are just some plastic clips holding this together, actually. But it felt like it might have been glued, also. And usually my first reaction to glue is to get the vise and just snap the glue apart. That is actually easy. There, open sesame. Cool. So there's the actual PL2303 chip. Then I assume that would be the line driver. What line driver is that? That is the line driver chip, ZT213. I don't recognize that manufacturer. I don't think that's Ztex. Looks like an unused space for an EEPROM or something similar. And then the connectors kind of soldered with the board in between the 2 rows. So in order to sacrifice the connector and hopefully not damage the board, I'm just going to cut the pins at the top. Alright, let's clean that up a little. Just going to flow a little bit of fresh solder onto here to help these come up. So this VFD, being that it already has a built-in serial interface and everything, we just need 3 wires. We just need ground and 5 volts. They both need to be able to carry a decent amount of current. And then our fairly pokey 19200 baud full-strength RS-232 serial connection. Okay, transmit is pin 3, which is what I wanted. So we want pins 3 and 5. So 3 will be brown in our current color scheme. And then 5 volts, of course, did not appear on the original serial port, so we're just going to snag that from wherever it's convenient. So ground, +5. Oh, it's blinking. See that blinking cursor? Oh, I've got a character. So we can type on this thing. Oh, it even scrolls. And we get backspace. Cool. So I just want to hack up this Python module so that instead of using my crazy kernel thing, it just opens a serial port. Whoa, this uses numeric Python? That's old school. I might have to convert that to NumPy. Let's see if any of the examples work. Ooh. What is VFD widgets? I made a text layout system? What even is this? Widgets and surfaces with gravity and stickiness? I've written so much software that I've forgotten about. Well, this is going to be a good starting point. I didn't realize I already had this much. I mean, I knew I wrote a bunch of code for this, but I didn't realize it would be stuff that I could still use. Let's get these back grounded and take a look at the filament voltage. So we determined that these groups of pins are all ganged together for, these are all supplying current for the filaments on the left side and then correspondingly on the right side. Oh, and it's changing frequency quite a bit. That does appear to be pulse width modulation. I wonder if that's related to the power supply or to the display pattern. It's like 15 volts. So let's see what the other side looks like. So the voltage actually seen by the filament is going to be the difference between these two. So it's not a particularly balanced waveform. It's not a very good AC power supply. So it's putting like 7 volts across that filament, 7 volts AC at 60 kilohertz. Interesting. So, I don't know enough about VFD optimization to know if this is an acceptable waveform, but it's interesting to see what it's doing. So the other kinds of signals we'll be looking for are the signals actually going to the individual dots, and then we have the signals going to these mesh grids that are in front of each column. It's not obvious how those are wired, since I think the wiring is on the opposite side of the VFD. I mean, this pattern should be hitting all the pixels. Ooh, there's our high voltage. Okay, so it looks like the filament is not writing on top of the high voltage, but the other way around. It's an interesting waveform that I didn't quite expect. Is that related to the wave I'm displaying, perhaps? No? Is that related to the brightness modulation? Well, there's clearly a lot going on here. It could be these are the columns and they have half on top and half on bottom. Let's see what one of these looks like. So those pulses are going up to 40 volts. Let's put one from this group on the green channel, and then one from the next group on the pink channel. I think that's our wave pattern. So I think so I think the red trace now is one of the column grids, and then the green is one of the pixels. That's great. All right, so it's doing PWM by changing the length of each column's chunk of time. So the kind of capacitive effect that we're seeing there is probably just some artifact of the way the power supply works, or like different loading on that rail. But the important thing is that the length of that pink pulse is changing as the display fades in and out. It looks like there's maybe a tiny gap in between columns, but not much. So these two groups in the middle together form one signal for each column of the display, so we only need 20. There's 10 on each side. These groups of 6 on either side are just the filament. But then I think everything else is going to be a grid of dots representing 2 vertically stacked characters. And so the back will just kind of have wiring for all of those. Let's try this program, which has some scrolling text. So that wasn't changing at all as that scrolls. This is probably a pixel from the bottom half of the display. So what if I start probing on the top half? Is that going to give me pixels for the top line? Looks like it. Alright, so we've got Fusion 360 here, VFD, and a pair of calipers. It really just needs to include things that I would need to take into account when designing a mount for this. So the board itself, the location to the connectors. So this is the leading candidate for a datasheet. Physical dimensions, page 10. Oh, 2 by 29 millimeter. I think this is it. Oh, that is dead on, 7.75 inches. 7.45 centers between these holes. Let's see if that matches. Yeah, that's great. I think we have our thing. Let's just check the height real quick. What does that say? Man, this is like a scan of a fax from 1940 or something. It's a vectorized fax. Oh, they're so hard to read. This should get us really close to the designer's intent. And so now we just need to center that in there. Centeredness is strongly implied by the original sketch. So there's a couple of fairly thick components here. So you can see there's the transformer on the left I was talking about. And there's the connector. Wow, there's like a legit ground test point over here. I think I'm just going to make kind of a box that covers most of this to that height, and then carve out a little extra room for these parts. It's looking better. So I mean, this isn't intended to be an accurate model. It's basically like a keep out zone, sort of. It's like when we're designing stuff, this is the envelope that we should leave room for. There's room for the electronics, room for the connector. And I think I do want this case to have some amount of a sunshade because, check that out. It's much easier to see than with the light hitting it directly. because I think I can have the pole mount take up some of the space and then have electronics kind of on the sides. So we could have the pole actually kind of hug pretty close to the display, and then wouldn't necessarily need that much plastic around this. I was thinking about flipping it around and actually having this mount in the front of a piece that has basically this shaped depression in the back. So you'd end up having kind of support pillars that come up and hold it by the screw holes, and then you'd have this pocket that holds most of the electronics, and you'd have kind of deeper sections for the power supply transformer and for the connector. And that also kind of lends itself to maybe a nice printability layout where, so maybe I place this with what would be the front of the display facing down on the printer. This would just kind of come back and have this U shape that envelops the pole and has cutouts for all the magnets. So the adapter right now has kind of a built-in, like a captive cable from the original serial dongle that this was. And I would rather have a connector, like specifically I think I want this to have a full-size USB Type B connector, since that'll be large and pretty sturdy, and I can easily incorporate that into a 3D printed design, I think. And I don't even know if I'm going to bother making a breakout board for the connector. I think I might just make a little 3D printed cavity that the connector can snap into, and then I'll just solder 4 wires from that to this board. This will be a fairly, like a relatively tight fit around the connector body here. Let's see if this is a realistic USB enclosure for this connector. I like to do this thing where I make really minimal test jigs for stuff that has tight mechanical tolerances and print those first and get that out of the way. So this area is kind of blank. That actually might be a good place to have snaps. There's no surface mount components on the edge, like near the edge of either side of the board there. Whereas over here we have surface mount components coming up pretty close to the edge, so it's not really going to be useful mechanically for anchoring. So this bottom side is kind of flat over here. It has circuitry over here. Oh, we've got a part. And possibly the camera's low on batteries. Let's go investigate that. It's a 3D printed thing that makes weird noises. I think a lot of what he likes about the 3D printed objects here are the strange noises they make. So, what part of this do you like, Tuco? I don't quite... Hey, is it the brim? The little plastic piece on the bottom that the printer kind of spits out to hold it down? Oh, there you go. You can kind of see that in there. Oh, I think that snap was what we wanted. Ooh, this might not need epoxy. Let's see what this is like with a connector. Oh, that feels great. Okay, Tuco, let's play. This was a good stopping point. This bottom edge, I think, maybe needs a little bit more clearance, because that's coming close to overlapping the metal. That's nice. I didn't hear it click that time, but I think that's an improvement. Didn't feel like I was about to break it in assembling it, and these clearances look a little nicer. Cool, so that looks weird, but that's basically the negative space that I need for this particular part. The cavity behind the VFD is a great place to put all the kind of temporary stuff that I want to cover up when it's all fully assembled. So in that case, I actually want the wiring to be facing toward the front of the VFD. And I want the connector to point toward the bottom, because that's where the cable is going to be facing. That's good rotation-wise. Now we just need to avoid this pole somewhat. So I think roughly I want it. Okay, so not all of these shapes are like viable for including in the final thing, because this is already like a portion of the plastic that we want to keep, whereas this is like a keep out region, and so is this. So in this, go. Okay, I think I can join these now, and then kind of carve out a hole for the connector to go through. There we go. That's the profile I wanted. So we have room for the little like wings to stick through. That'll probably be covered over with something else eventually. And then this is the actual catch that holds it in place. Then some chamfers to kind of help guide it in. So you'll notice I still have not taken the support material out of this. That was partly because I noticed, even just as I was taking it out of the printer, that it seemed like maybe there was at least like 1 or 2 layers that didn't have great bonding. So given how thin this edge actually is, I was worried that this was just going to break. So I actually didn't want to take out the interior until I reinforced it some. I've already treated this 3D print with basically this brush-on epoxy, 2-part epoxy that you mix up and brush on, and it has a pretty nice viscosity so that it manages to fill in the space between the 3D printer layers. The brush is still very hard. This is like a foam composite now. And most importantly, I put in the magnets before doing that coating, because there's no way they would have fit afterwards. It's a very tight fit for the magnets. And now the magnets are actually embedded under this epoxy coating, which I think makes them stronger and makes the surface pretty smooth. Yeah, I like the way this shape came out. Okay, there we go. Press fit. Yay! That's nice. And it holds the cable on by itself just fine. I do think it would look better with some contrast. Some more contrast between this on the outside. I could actually make this look nicer with a slightly asymmetric paint job. I just had this piece of tape laid that way to get it out of the way, but it gave me the idea to kind of make this angled. And so I didn't actually want to make it structurally angled because that would have made it a lot harder to print. But now I'm thinking that maybe I want it to kind of look like it has that angle. So I actually have a thicker black line across the bottom and a thinner black line across the top. I feel like I maybe want to lightly sand this to help the paint stick, because the epoxy is super glossy. I put on one coat and then another coat some hours later, and then it's had like overnight to dry. And I am largely happy with that. So that's the top. Haha. Yeah, I think that paint job was definitely an improvement. Oh yeah, I did arrange this so that the USB port points toward the USB port, and the serial port points toward the serial port, and the schnozberries taste like schnozberries. Yay! There's barely enough of that snap left for it to snap in. That's how it was designed to fit. Cool. It's right in there. The idea behind this is this would solder around there. Let's do the other joint. A few more wires. I would use probably a little bit of hot glue or something right there as a strain relief. So we should expect to see ground, VCC, D-, D+. So now let's just cut these roughly to length and then prep them by stripping them and putting some heat shrink over. And these will run down this way. These will run over to the connector. Trying to keep it off the plastic as much as possible, but there's going to be a little bit of surface damage. That doesn't matter. So this I'm just using to reinforce the solder joints between the wires and the serial board here. I think we are ready to put this together. And I think this can just go in. I don't know that I'm going to need to guide the wires especially. I think that's in. So for the screw situation, oh, I think I might have just stripped the insert on that side. Sigh. Well, it's still holding pretty well. Not gonna push my luck. I think that might be done. There, that's at max brightness, which looks a lot brighter in real life. It's still a little hard to tell when the studio lights are pointing directly at the phosphors, but yeah, I'm just kind of testing out the grip. It's pretty good. And it seems to seat into place with a little bit of a push. You can see the circuit board in there. Look at this side view. Yeah, it does kind of look like a cash register when it's at the very top of the pole. And the back came out so shiny. Big old bumpy hips. Yeah, it's like a combination of friction fit and magnets. And then that kind of takes a good tug to actually remove it. Well, that's pretty much what I was after. I like that black paint job. I'm happy about that. Happy that came out like it did. This is the abstraction around the VFD that I mostly yanked from my older Python code, just with slight modifications to take out the stuff I didn't need. I wrote my own new widgets to go on top of that, and this I tried to keep pretty basic too. And so these classes are all just Python objects that I keep around, and if they need to do their own stuff, they do it on a thread, and they all just get displayed by being converted to strings. So these are some processes it looks for. These are some directories mounted on the network where all the outputs end up going. I think that's what I wanted. Okay, so all of this stuff should show up, but at a lower priority than this one, which I don't think is currently running. And then I can turn that one on and off, and we should see the display brighten and dim. Ooh, now you can see it be super dim. Nice. It looked like it did the right thing. Well, the dim mode is very dim, but I think that's fine. Like, it'll keep the tube lasting longer, and I don't need the brightest clock ever, especially not at night. Oh, Oh man, what good timing. Tuco has a bolt to play with to end the stream on a kitty sort of note.